Okay, good morning, everyone. Just some raise of hands before I start my presentation. How many of you are first time to Cisco Live? Wow, welcome, warm welcome to you all, and welcome back for the others. To introduce myself, my name is Mahesh Nagireddy, Technical Marketing Engineer. I'm currently working on software-defined access. Been with Cisco for close to 10 years. Total of 20 years industry experience in operation, design, pre-sales, and currently in marketing. When I joined Cisco, I was a TME for Cat 6K, Cat 9500 switches, and then later I was a TME for Cisco ISE for some time, and now working on software-defined access. So with that, let's go ahead and start. I would highly recommend to log into the WebEx team space. There are two reasons. One, you can post all your questions there, and this space would be monitored for a couple of weeks. And also, you would get our email addresses there so that if you have any questions later, even after Cisco Live, you can reach out to us and we would be happy to help. Right? I have just 1 hour to present a lot of content, so let's keep the questions minimal. I'll take 1 or 2 questions at the end of some of the sections. Please raise your hands. I wouldn't be able to walk through because there's too much of crowd here for me to, which I would love to do that, but I don't think it will be possible. So raise your hands. You will get a mic so that you can voice out your questions on it. At the end of the presentation, please reach out to me if you have any further questions. I have some giveaways to give out, so please let me know. Okay. The way I've structured this presentation is more on how you go integrating Cisco DNS Center with ISE, and then what are the steps you have to do on Cisco DNS Center to fully bring up some of these settings, right? And then we will look at what are the segmentation strategies we support in Cisco DNS Center or Cisco SD Access. We will look at some of the use cases what ISE brings into Cisco DNS Center, right, or Cisco SD Access Fabric. As we all know, Cisco ISE is a leading industry's network access control and policy enforcement engine, which basically administers your wired endpoints, wireless endpoints, your remote access VPN connections as well. It basically lets you know who is the user based on the credentials, what's the mode of connection is coming in through, whether wired, wireless, or remote access VPN. How is it getting connected to the network? What time did it connect to the network, right? What's the posture or profiling of that particular user or the endpoint, right? We get all this information from ISE. Again, nothing new because most of you already have Cisco ISE as your NAC. So whatever Cisco ISE does today, we will continue to do the same even when you integrate ISE with Cisco DNS Center. Right. So I just wanted to reiterate some of those points, what ISE does today. So coming to the use cases, the first use case I want to call out is guest access. Today we used guest access for wireless, but today if you want to configure guest access with wireless, there are multiple touch points you have to do. One, you have to do some configurations on the wireless LAN controller. You have to log into ISE, create some portals like self-registration portal or sponsor portals. So it's around 8 to 9 steps what you have to go through on DNS Center and ISE. On wireless LAN controller and ISE to get your complete ISE workflow or guest workflow up. But what we're doing with DNS Center and the power of automation is you just log into Cisco DNS Center. We have workflows in the DNS Center where you can go through the guest workflow. With that workflow, you just do 4 or 5 steps. And with that, DNAC will take care of logging into WLC, doing the required configurations on WLC. DNAC will log into ISE at the back end if it's integrated, and then it will take care of all the portal configurations what you used to do on ISE before, right? So that's the simplification what you get integrating DNAC with ISE. And the second use case is host onboarding. This is not new to us. Today in traditional networks, we use .1x, MAB, or even WebAuth to authenticate users or devices. We will continue to do the same even when you move to Fabric or SD Access. The third use case is group-based access control. This is one of the segmentation options what we have today built into the Fabric. This is basically based on Cisco's TrustSec architecture. So we use those security group tags to further segment your users once they are onboarded into the SD Access Fabric. The fourth use case is assurance. So today, if you log into ISE and look at the context visibility dashboard, you would usually identify the endpoints using a MAC address. But you don't have an IP to, you don't have an IP to user resolution. You don't know who is the actual user behind that particular MAC or IP. What DNS Center gives you is that IP to user resolution, right? So you can go on DNS Center UI, go into the assurance page, type in the username or type in the IP address, type in the MAC address. It will clearly tell you who is the user, to which port is connected. If it's a wired user, if it's a wireless user, it will clearly tell you how is he getting connected to the network as well, through which AP or through which wireless LAN controller. The fifth use case is device administration. Again, this is not new. We authenticate network devices today like routers, switches through a protocol called TACACS or Radius. We continue to do the same with DNS Center, but there's a lot of automation which happens at the back end, because today if I have to enable device administration, I have to log into every single switch or maybe write a script to push some AAA configs to enable TACACS or Radius for device auth. This is completely automated by DNAC, right? Moment you add a switch to a site, moment you add an AAA servers to a site, automatically DNAC pushes all these configurations to that switch. So there's a lot of automation which happens at the back end with that integration. The next use case is endpoint analytics. This is basically the profiling, what we do on ISE today. ISE has certain probes to do profiling, but we have enhanced that profiling options with endpoint analytics. I have a dedicated slide for this. I'll go through that in much more detail. The next use case is policy analytics. So today, when you configure policies on ISE, you just go with an assumption that this particular user or an endpoint might talk to so-and-so destination, or even when you try to set up your firewall rules. But what DNS Center gives you is, we use net flows to export data to DNAC so that we know what communications is happening between two SGTs or between two users, right? So we can lock the network down later, maybe in day N. So we can monitor the network for a couple of months and then lock the network down with just a click of a button. So that's the visibility you get with policy analytics, which is something missing today. If you have Stealth Watch, yes, you can certainly get that info. If you don't have Stealth Watch, then we are missing that piece. So that's an important information what you could get from Cisco DNS Center with policy analytics. And last but not the least, the ecosystem what we have built. So DNS Center has a PX grid integration, so it can integrate with other vendors, and we can certainly share context with other vendors who can do PX grid services as well. So now let's look at some of the ISE deployment options, right? As we all know, ISE is network access control, policy enforcement engine. What makes up, how do we identify users? We identify users through a process, through the credentials what they share, and those credentials can be certificates, MAC addresses, or passwords or token, any of those methods, right? So that's how we identify users, or ISE identifies users. But how does these credentials reach ISE? It reaches ISE through a process called authentication. So switches do send a Radius packet back to ISE, and through that authentication process, the ISE identifies who is this user and what level of access should I give for this particular user, right? And again, ISE just can't do that alone. It needs some connectivity to external services, maybe your Active Directory or any other resources what I've just listed out there, right? So once ISE has integration to some of those external identities, then it can certainly authenticate that user and then give the right level of access. So when it comes to deploying ISE, nothing changes with Fabric, or when I say Fabric, it's SD Access Fabric. So the way you deploy ISE today, whatever scale, whatever deployment options you follow will continue with SDA, right? You can either go with, if it's a small lab environment, you can certainly stick with a VM version of it, where you enable all those ISE personas, the PAN, the MNTs, the PSNs, right, the PX grid. You can enable all these 4 personas on the same VM or an appliance, so that it's just one box doing your ISE functionality, right? So nothing changes. If it's a medium or a small deployments, you can certainly follow some of those options which are listed out there. You can have active standby ICE nodes. You can have kind of a distributed architecture with PAN and MNT running on individual appliances. Then you can have up to 5 PSNs, right? All this depends on scale what you need. Based on your scale, you can certainly pick some of these options. And anyway, the well-known recommended option is this distributed one, where you have a dedicated PAN, a dedicated MNT nodes, and we support up to 50 PSN nodes in a full-blown ICE cluster, right, to make up to this 2 million endpoint scale. Right? So the reason I'm calling out this slide is nothing changes how you deploy ICE today when you move to Fabric. So what are the protocols we use to integrate DNS Center with ICE? So there are primarily 3 protocols. HTTPS to begin with, where ICE will use DNAC will use HTTPS to log into ICE, and then establish a trust relationship between DNS Center and ICE. And the way we do that is by exchanging certificates. So DNAC logs into ICE, exchanges the certs between both. So once a certificate exchange happens, then it will use those certs to establish the trust relationship between DNS Center and ICE. And along with that, we also use REST APIs. There are 2 use cases with REST APIs. One, DNS Center can pull all the nodes on the ICE environment, because the only IP address we give on DNS Center is your PAN IP, right? So only the administrative node IP address. But with that IP address, it can go pull all the entire ICE cluster, like what's the MNT IP address, what's the PSN IP addresses, how many PSNs you have within that cluster. It can pull all that information through that REST APIs. Another use case why we use REST APIs is, if you configure a policy on DNAC, it will automatically push that particular policy with REST APIs at the back end to ICE. Right? So that's another use case why REST APIs are used. The third one is PX Grid. This is basically to exchange context. I think I called out that in the assurance use case, to exchange context both ways, between DNAC and ICE, and between ICE and DNS Center. So before you even go integrate DNS Center with ICE, there are certain services which you have to enable on the ICE side. One, enable PX Grid, because DNAC needs PX Grid access when it integrates with ICE. Second thing is you need to enable some ERS read-write privileges as well, which I've just called out there. So these are the only 2 things you have to do on ICE side before you integrate DNAC with ICE. So once that integration happens, as I mentioned before, certificate exchange happens. ICE uses the REST APIs to pull down all the ICE nodes, and then there was. Okay, so there's some animation which is lost on that slide. There was supposed to be a snapshot here which calls out what information we have to input into DNS Center, but I'll just verbally highlight that to you. So only information we key in on DNS Center is the PAN IP address, the super admin credential, the username and password of ICE, and the FQDN of ICE. Those are the only 4 information what you need to enter on DNS Center authentication and server page. So once you key in these 4 variables, and once you click save, it automatically starts this integration process at the back end. We have seen ICE deployments with load balancers, because a lot of customers have load balancers and PSN behind load balancers. So if that's your deployment, you have an option on so these were the parameters which I was just talking before, right? The PAN IP address, the shared secret is nothing but a key which ICE can use to talk to all the switches. The username, passwords are the super admin credentials of ICE, the fully qualified domain name of ICE, and then the subscriber name gets pre-populated. So this virtual IP, what you see here, that's your load balancer IP. So if you have multiple load balancers, you can certainly key in those IP addresses so that we can use those IP addresses later in the settings page on DNAC. So once you integrate ICE, that's how it shows up here. Currently, state is active. We have 1 ICE. And we can only integrate 1 single ICE cluster with DNAC today. We don't allow more than one ICE cluster. You can have multiple AAA clusters or AAA servers, but only 1 ICE, right? So that's the kind of limitation what we have today. We know that there are customers who have They're using one ICE cluster for wired, one for wireless. They're using one for maybe wired wireless and one for guest, right? There are multiple clusters. But today, with the current shipping releases, you can only integrate one ICE with DNA Center. But you can certainly add multiple AAA servers. And the AAA servers can be another ICE cluster. It can be any other third-party AAA server as well. So when it comes to authentication in a fabric, right? Again, this goes back to how we used to do traditional authentication on TrustSec environments. So in traditional networks, we used to have something called a closed auth. We used to have easy connect on ICE, and we also used to have a monitor mode on ICE, right? We have similar equivalent options on DNA Center as well. So this is the DNA Center UI. And if you look at this authentication template, you have those three options. Closed auth is equivalent to the closed auth on your traditional network. Low impact mode is nothing but the easy connect. And the open auth is the monitor mode on ICE. And here is the relationship between them. So if we say monitor mode or open auth, it's only for visibility. Whether an endpoint authenticates, he shares valid credentials or not, still he'll be onboarded to the network, right? So this is how we will just monitor the network maybe for a couple of months, and then you can go transition to one of these options. Either you can go to the low impact mode, or you can go with closed authentication as well. What low impact mode does is, the endpoint will have some basic access to begin with. Maybe the endpoint can talk to an AD server, endpoint can talk to DHCP, DNS, or maybe if you have a thin client, the endpoint can talk to a thin client server as well. So you can give some basic access to begin with, and then once the endpoint authenticates, then you can give full access. So there's a process called change of authorization, COA. Through that process, we can give full access to the endpoint. That's easy connect or low impact mode. Closed auth is every endpoint behind a port has to authenticate before it gets network access. So without authentication, there's no network access. It can be an IP phone, it can be multiple workstations, but every endpoint has to authenticate, right? And this is the most secure method. And by default, we would recommend to go with closed auth, but we also understand day one, you just can't go with closed auth because of various reasons. So you can certainly start with monitor mode and then either move to one of those options, right? Easy connect, the low impact mode or closed authentication. In the traditional networks, we had a lot of options in the CLIs to tweak some of these variables when it comes to .1x, to map fallback, .1x timers. We have similar options on the DNA Center UI as well. So once you go into this template editing mode, you have an option here to choose which should be my first authentication method. Do I want to use .1x to authenticate an endpoint? Do I want to use map first? So depending on the endpoint types you have, you can certainly choose. But again, this is specific to a site. So once I change from, let's say, .1x to map, map would be your default first authentication method across the entire site. So if you have hundreds of switches in a site, all switches will have map as your first authentication method. We don't have further granularity today, but this is the only options what we have on the UI. So if there are any further use cases, let me know. We can certainly work it out. And when it comes to timers, right, we used to use some CLIs before to change these timers. Here is just a toggle button, right? You can toggle this particular bar here to, to set the timers. If you want maybe your .1x timers as 7 and reauth timer as 2, you can certainly set that with the toggle button there. And another thing is, on the traditional networks, we used to have authentication modes on every port, right? Single host, multi-host, multi-domain, and multi-auth. What multi-auth means is you can have one IP phone behind a port, and you can have any number of endpoints, but all the endpoints have to authenticate. That's multi-auth, and that's the default mode, right? Every endpoint, you can have a hub or another layer to switch behind that port, but every endpoint has to authenticate. The other option is on the UI. So if you look at this number of hosts, you have single and unlimited. So unlimited means multi-auth, so one voice, multiple data. Single means one voice or one IP phone and one data and one workstation or a PC, right? Those are only two options available on the UI. So you can either go with multi-domain or multi-auth. By default, it's multi-auth. And when it comes to your Easy Connect, we also give you an option to change that redirect ACL. So you can specify here what that basic access should look like for an endpoint. Like, should you have access to DNS, DHCP, domain servers, you can edit this particular URL here, or this particular access list kind of thing, what you see here, to give the basic access and then do a change of authorization once he fully authenticates. So far what we have seen is integrating DNAC with ISE, right? And changing those templates. What should be my default template? Whether I should have MAB as my first authentication method or .1x. The next thing is onboarding devices to DNAC. Again, there are 3 ways to onboard devices to DNS Center inventory. It's like any other NMS tool. So today, if you have an NMS tool, you go discover devices on the NMS tool, right? To input or onboard devices. You use the IP address, you use SNMP credentials, you use Telnet or SSH to onboard. The same thing holds good even on a DNS Center, because DNS Center is kind of an NMS tool to begin with. But there are 3 options to onboard. If it's a greenfield environment, let's say you're bringing up a new branch or a new headquarters, you have those first 2 options. The first thing is called LAN automation. This is kind of a fully automated way of onboarding a switch. You don't have to log into console. You don't have to do any configurations on the switch. Brand new switch, out of the box, power it on, connect it to an upstream switch, and we will do all the configurations on that switch. We will enable a routing protocol called ISIS. We will configure a loopback IP. We will configure a cross-connect IP address. We will push down all the best practice configurations what's required, right? So that's LAN automation. And this is the default or recommended method what we recommend if you're running a fabric. If your end stage is to run a fabric, go onboard devices with LAN automation so that we push all the best practice configs, including your system MTU. Because for a fabric, we need jumbo MTU capabilities, right? We need BFD between two switches for faster convergence. So all those best practice configs are pushed with LAN automation. The second option is plug and play. If it can be a greenfield or a brownfield, LAN automation uses plug and play at the back end. So this is an agent which runs on every single iOS XE device. When it powers up, it will look for an IP address. Once it gets an IP address, along with the IP address, we can also push down a controller IP. In our case, it will be a DNS Center IP address. So now the switch can talk to DNS Center. Once the switch can talk to DNAC, then I can push down whatever iOS image I want, whatever template I want as a day 0 config, right? That's PNP. But LAN automation is basically, you don't have to select a switch by switch once it does a call home back and then onboard it. It's completely automated, right? That's the difference between LAN auto and plug and play. But if it's a brownfield environment, you already have a network which is currently running, up and running, and you want to just build a fabric on top, so you have to discover an existing network onto DNS Center. If that's your use case, you can certainly use the manual discovery option. So this is where, like any other NMS tool, you key in the IP address of the switch, the loopback IP or management IP, SNMP credentials, your Telnet or SSH access, and then you should be able to discover that switch, right? So those are 3 ways how we onboard. But once we onboard, what configurations have to push to the device is what this provisioning step decides. In DNS Center, there is a setting page where you define some of these. A particular site, what AAA servers it should have, what should be my PSN nodes, what should be my NTP server, what should be my domain ID, what is my DNS server, right? What if you have a StealthWatch integrated, what should be my StealthWatch IP address? So all this you define in the setting page once on the DNAC, and once you do this provisioning, this is when we will push down all these configurations to the switch in one shot, right? You don't have to do this box by box. You define it once, select the switches, provision it. DNAC will go log into all the switches and provisions all these configs what you see here, NTP, AAA, TechAX, whatever you have done on the network settings page, everything will be pushed to the switch, right? That's the power of automation. Another thing what it does is, today in a traditional network, if you have ISE, you have to log into ISE, add a device into the ISE database, right? Because if ISE has to manage the device, you have to add it manually. But DNAC does that for you at the back end. So moment you discover devices through any of these onboarding process, DNAC will automatically add the device into ISE, into the default NDG group or the network device group. That's all taken care at the back end, right? You don't have to log into ISE to add a device. So the next thing is, okay, we had configured a template before. We had done some changes on the templates. Once you come to a particular site, so if you look at this, this is site A. I've already built a fabric. Again, I'm skipping the step of building a fabric here because this session is more about what's the role of ISE in a fabric. So I've skipped that step. But let's say once you've onboarded the device, you built a fabric, and then you have an option here in this host onboarding tab where you can select what template I want for a site. Do I want to go with closed auth, or do I want to go with open auth, or low impact, or no auth, right? You have 4 options to pick. You can certainly select one of those options, and that will be by the default option for the entire site. But this is a global config. And once you do this, once you select closed auth and click deploy, here are all the configs which DNAC will push to the switches. It will push the IBNS 2.0 config. So this is the configs which we usually use, for .1x or map related, right? When you want to authenticate a device. So all these configs are pushed, the class map, policy map, service templates, all these informations are pushed by DNAC to all the switches in that site. If you have hundreds or thousands of switches, all the configs are pushed to all these thousands of switches. Right? And the next thing in the host onboarding is adding an IP pool. So we have something called virtual networks. This is another segmentation method, what we support in Fabric. So if you can have multiple virtual networks, and then you can add IP pools into the virtual network. So what you see here is, I have a virtual network called guest, an SJC15 VN. So you can have any number of virtual networks. We support up to 256 VNs, right? This is one of the segmentation methods what we support. But once you associate an IP pool to a VN, right? And this is when, again, DNAC will push some of the other configurations back to the switch, like IP device tracking, right? Creating an SVI on the switches. So all those configs are pushed at the back. In the previous step, we had done a kind of a global config where I had selected closed auth as my authentication method. But what I want to go ahead and override that on per interface level on a switch. Because let's say you have a switch, you have an access point connected, or you have a particular kind of an endpoint which is connected to one of these ports, and you want to go ahead and change from a closed auth to, let's say, a no auth on that port. So the DNAC UI, you have an option to change that as well. You can select a port, then you can click on assign, and once you click assign, it'll ask you to choose what kind of device is getting connected to the port. If you want to configure an open trunk, certainly you can do that with a trunk config there. If you have an access point, you can certainly select an access point. So once you select server, it becomes a trunk. Right? And then you can specify what IP address pool I want to use, what VLAN, what template I want. So this is kind of overriding your global config or global setting what you had on a port level. And once you do this, again, DNAC will log into the switch, push down all these particular commands onto that particular port. Okay, so let's understand the two segmentation options what we have in Fabric. So by default, what we meant by macro segmentation is nothing but the VRFs what you have configured so far. So this is kind of a device level segmentation. On the DNA Center UI, you see virtual networks. So once you create a virtual network, it's nothing but at the back end, we are creating a VRF. So virtual network is equal to a VRF, is equal to a Lisp instance ID. In a fabric, in an SD Access fabric, Lisp is the control plane protocol, right? So Lisp has its own instance IDs. So VN is equal to VRF is equal to an instance ID. All three means the same, right? But on the UI, you only just go create a VN, right? You just give a name, and the moment you go click save, it automatically DNAC logs into all the switches. It configures a VRF, and it also configures an instance ID as well, right? And by default, if you have multiple VNs, there is no communication between them. Let's say you have a VN called users, you have a VN called things. They don't need to talk to each other, so by default, there's no communication. So this is the first level of segmentation what you can have on your network. Let's say you have badge readers. Why do you want a user to talk to a badge reader? Why do you want a user to talk to an IP phone? He doesn't have to do that, right? So you can certainly separate those two out. And we've also seen customers having two separate networks, one for users, one for some of these IP cameras, the building management systems, right? You don't have to run two separate parallel networks. You can certainly combine that with SDA. You can have multiple VNs within the same network. It's kind of virtualizing your switching or the routing environment is what is what this segmentation gives you. The second segmentation option what we have is micro. So within the VN, let's say I have users as a VN, but within the VN, there are employees and contractors, right? By default, I don't want employees to talk to contractor, right? I can do that. I can push down an SGACL policy. I can give a SGT tag to an employee. I can give a tag to a contractor. I can say I don't want employee to talk to a contractor. Yes, the policy gets pushed. There will be no communication between those two, right? Another thing is within the group itself, like within this HVAC system, I don't want each devices to talk to each other. I can certainly do that with SGT tags, right? So it's further granular level of segmentation is what micro-segmentation can provide you. On the DNS Center UI, we released this app in this 1.3 release. It's called Group-Based Access Control. There were a lot of benefits this app brings in. It will kind of, the TrustSec policy matrix, what we had on ISE, it's now available on DNS Center, so you don't have to log into ISE to configure the TrustSec policies. You can do it right from DNS Center UI, so that's what this app gives you. We also gave you an option to integrate or use third-party NACs. Like let's say some of our customers had, they didn't have ISE as their NAC, they had other third-party NAC servers, so this particular app or this particular feature gave you an option to integrate with any other third-party apps. I have a slide at the end which talks about what are the options available integrating third-party NACs. I'll go that in much more detail. And also this particular app gives you an option to create policies. It also gives you an option to create security groups right from the DNS Center UI itself, which you don't have to log into ISE to create an SGT. Right? The REST API connection, what we have at the backend, takes care of that. So you just go create an SGT on DNAC. It will push that at the backend using those REST APIs to ISE. And you can also create access contracts. These are nothing but your SGACLs, what we call on the ISE side. This I'll skip for now. So we have built a fabric. We have specified the authentication templates. Users are authenticated. They will get a tag, a security group tag. How do I classify this, right? Do I authenticate the user with ISE and get a tag? Or what if my endpoint is not capable of doing .1x, right? In that case, I can certainly go with mapping a subnet to an SGT as well. That option is available in the DNS Center UI. You can also go with mapping a VLAN to an SGT. You have an option to map a port to an SGT, right? All these options were available in the traditional configs or on CLIs, but now you have similar options on the DNAC UI. And the power you get is do it once, it just pushes it to all ports or all the switches. So we have classified the endpoints. How can we propagate this? Because I need to carry this tag from one hop to another hop or from one part of the network to another part of the network, right? The best or the recommended classification is your inline tagging, which means everything is carried in hardware. You don't have no software involved, right? And that's the best or the recommended option what we would recommend to do. But there are other options like you can use IPsec to carry, like let's say you have a WAN environment, your WAN doesn't support TrustSec. Let's say it's a third-party service provider WAN. It obviously doesn't support TrustSec, so you can certainly build an IPsec tunnel. You can build a DMVPN tunnel if you have an internet as your WAN, right, to carry these tags across. But when you come to Fabric, VXLAN is the data plane protocol what we use, and VXLAN carries this tag by default in its packet. So when the packet goes from your access switch to your core, the VXLAN header will certainly carry these SGT tags and the VN or the VRF information by default. So let's say we have headquarters, branch. I have a WAN in between. I can't carry the tag because service provider doesn't support, and I don't want to use IPsec or DMVPN, any such tunnel termination options. The next option what you have is something called SXP. Again, this is nothing to do with Fabric. ISE supports this from a very long time. Even the switches support this. You can build an SXP. It's called Security Group Exchange Protocol. Security Group Tag Exchange Protocol. So you can certainly build an SXP between two switches, two routers, or between ISE and switch, to download these bindings, because I'm not carrying this tag end to end, so I can certainly build an SXP from ISE to maybe a firewall or to a switch, or between two switches or two routers, and then exchange these tags. That's another option available. But again, we don't recommend to go with SXP. The reason being, there are some scale limitations with SXP. The newer ISE releases do support this IP to SGT binding exchange over PX grid as well. Because of the limitations what we had on SXP, we do support these are only on the next gen firewalls which supports this PX grid. So you can certainly use SGT or via PX grid to exchange those bindings as well. Okay, so within a fabric, if today I highlighted that we use Lisp as the control plane, VXLAN as your data plane. Let's see how that end-to-end segmentation will be carried, right? So this is a single fabric site. You have edge node 1, edge node 2. Let's say there are two users who are connected to each edge nodes. So employee connected to edge node 1, he gets an SGT employee. Another host gets connected to edge node 2, he gets a SGT contractor, right? So now let's see how. Let's say if edge node, the host one wants to send a traffic to contractor, how does that entire packet flow happens there, right? So once the host gets connected, the switch will send something called a map reply or a map request to the control plane node. This is all Lisp communication. The only thing it's asking in that map request is, where is this particular host who is called contractor? The control plane is kind of a brain of your entire network. So it knows where each hosts are and behind which edge nodes. So the control plane replies back saying that contractor is behind edge node 2, right? So once this edge node 1 gets that information, it will build a VXLAN tunnel between edge node 1 and edge node 2. And that VXLAN tunnel will carry that source tag of employee. Right? So once the source tag is carried, so what the blue icon, what you see there, that's the tag. So once the source tag is carried to edge node 2, now edge node 2 has both tags. One, the source tag, which came through VXLAN, and it also has a destination tag because this user authenticated with ISE, and ISE already gave a tag to contractor. So since now it has both source and destination tag, we can do an enforcement right on the switch. Right? So always that egress enforcement is what we call this. So I can certainly enforce it. So this is how we carry the tags within a fabric, right? So if you have a 2-tier, 3-tier architecture, doesn't matter. We seamlessly carry those tags within the fabric. And that's the header, how it looks like, which carries both that VN or VRF information with tags. That's a VXLAN header. So if I want to enforce outside my fabric, let's say, so what I'm trying to do here is, I have a fabric built, I have my edge nodes, I have my borders, and I have an IP transit, which is nothing but an IP handoff to the external world. I've built a policy here saying employee to production servers permit, right? So moment I do that, the policy gets pushed to the respective devices. And what I'm trying to show here is, you can push the policies to an edge node, an extended node. You can push the policies to the border as well, right? By default, the enforcement should happen on the egress switch. But what if I want to do an enforcement on the border? You can certainly do that. But as I said, to do an enforcement on any device, you need both source and destination tag. Source tag will anyway be carried to the border, but I don't have a destination tag. That's when you can use either an SXP as an option, or you can use a static binding on the switch as an option. But the message I'm trying to highlight here is, by default, it's the egress switch which does the enforcement, but you have an option to enforce it anywhere in between as well. So we have this device called a fusion device in a fabric. This is nothing but a device which connects to the border node in a fabric. And what this fusion device does is, it route leaks between two virtual networks. So the previous VNs, or the VNs what we have here, we have user VN, we have things VN. Let's say for some reason you need communication between a user virtual network and a thing virtual network. So if you want to do that, by default, they're not allowed, but you can use this fusion device on the top to do that route leaking. And we use BGP route targets to route leak, right? If you're using this method to route leak, by default, when the packet is sent out from the border to the fusion, the border removes that SGT tag. It's no more carried forward. If you want to still carry the packet up to the fusion and then get it back all the way down to the egress switch, you have to enable something called inline tagging on that port, right? It's just 2 commands which you have to enable on that port. So the moment you enable inline tagging, the packet will be, the SGT tag will be seamlessly carried all the way up to the fusion, hairpinned back because the host is still in the network, and then you can certainly enforce it on this egress switch, right? So you have to make sure you enable that inline tagging on those uplinks, how many ever uplinks you have. I highlighted about analytics on Cisco DNA Center. Endpoint analytics is one of the use case which I highlighted, which ISE brings onto the table when you integrate ISE with DNAC. Today, as I said, ISE has around 10 probes, SNMP probes, DHCP probes, Nmap probes to profile an endpoint, right? But that is not like it can profile all the endpoints what we have in the network. Maybe it can profile 60 to 70% of endpoints. This particular feature called endpoint analytics, we're enhancing that profiling. So what we're doing with DNA Center is, DNAC will now have multiple inputs to profile an endpoint. One of the input may be the ISE probe. The second input can be all the network switches have something called DPI, or something called an N-bar engine, right? So we export this information back to DNA Center because the switches know that each endpoints, what ports and protocols they're using to communicate. So based on this, DNA Center should be able to profile what kind of an endpoint it is. If DNA Center can't profile it, we also have integration with our AI ML cloud. So that information will be sent to AI ML cloud so that the AI ML cloud can give you suggestions on what kind of an endpoint it is. So that's the second one. The third one is if you have integrated DNAC with ServiceNow, or if you have a CMDB on your ServiceNow, we can certainly get some of the inputs from CMDB as well into DNA Center, right? So that's the third probe what DNA Center can use to profile an endpoint. If none of these options work out, we also give you some static tools on the DNA Center UI itself, where you can certainly map a particular endpoint MAC address, and you can highlight what kind of an endpoint it might be. Let's say you have a new IP camera. This camera can't be profiled either by ISE or by AI/ML or by DPI-based packet inspection. You can certainly statically configure it and input that to ISE. So now input that to DNAC. So now DNAC, with that, all these 4 or 5 inputs, it can give you up to 99% of accuracy when it comes to endpoint profiling, right? So this is a feature available. Again, this works. Either you have Fabric, you don't have Fabric, it doesn't matter. It works for both. Any questions so far? I think I just went through it, but anyone has any questions? Happy to answer. No? Okay. So group-based policy analytics, I talked about this on a very high level before. So today, let's say you have cameras, you have log servers, so all these are SGTs. We don't know what kind of communication is happening between 2 endpoints, right? Let's say you have an endpoint by name camera, you have an endpoint by name media server, you have no clue what communication happens unless you do some kind of a net flow export, or you send the traffic through a firewall and figure out what ports and protocols are currently being used, right? But this is an application or app on the DNA Center which gives you that information, right? So that you can monitor your network for a couple of months, and then with just one click of a button, lock your entire network so that later, day end, once this policy is pushed, between cameras and log servers, whatever ports and protocols were used before, those are the only ports and protocols which will be allowed, right? No further communication. So you can monitor your network, then with that deploy button, you can certainly go down and push policies so that only those communications are allowed and everything else is denied. This is kind of a visibility what we're trying to provide with policy analytics. So this is the slide I highlighted. I'll talk about third-party AAA NAC integration today within Fabric. So there are 2 options. The first option, what you see on the left-hand side, this is where ISE is acting as a proxy. So we have a third-party NAC. Third-party NAC is integrated with Cisco ISE. So all the authentication requests from the switch will hit ISE. ISE will act as a proxy, and it will, at the back end, query the third-party NAC and wait for the authentication response. Once the third-party NAC sends a response, along with the response, either accept or access deny, it also needs to send this AV pair attributes. So based on those attributes, ISE can now push down the respective policies to the switch, right, for that particular user. So this is the first method, and this is the recommended method as well, because this is fully been tested, and Cisco TAC and Cisco supports this. The second option is, we have customers who already are using third-party NACs, and the integration is already between the third-party NAC and the switch, right? But when they move to Fabric, they still need ISE, because ISE, the third-party NACs doesn't support SGTs, right? We still need ISE for micro-segmentation. So they have to go with ISE or integrating DNAC with ISE, but they don't have to change the authentication methods what they already have. The switch can authenticate with third-party NAC, and once the authentication happens, the third-party NAC should similarly push down those AV pair attributes, and once the AV pair attribute hits the switch can now talk to ISE and pull down the policy what's required for that particular endpoint, right? So this is kind of an offline method, but this is fully recommended. If you already have a third-party NAC, we would recommend to go with this option. But if you're already doing this, we officially don't support it, but it still works. Right? Any questions? This is an interesting topic. I want to take the remaining 15 minutes what I have to cover this one. No questions? Okay. So this is a feature which we introduced back in 1.3 release of DNS Center. So today you can integrate, or before this particular feature, the options were you can integrate DNAC with one single ISE. So if you have 5 clusters or 10 DNAC clusters, every cluster has to integrate with its own ISE cluster, right? There was no option to integrate multiple DNACs with one single ISE, right? So here is an option 2 where, before I talk about option 2, I want to call out one thing. So there are 2 types of data which gets exchanged between DNAC and ISE. One, the ST access data. So the virtual networks what you create on one cluster, I want the same VN to be available on other DNAC cluster. This is one data, right? The second data is the policy related one. If I create a policy, a TrustSec policy on one DNAC, I want the same policy to be available on multiple other DNACs. So these are the 2 types of data which gets exchanged through ISE. If you're not running SDA today, you're still using DNS Center to, let's say, manage your entire network, right? Because DNAC does a lot of other things than SDA. SDA is just one piece or one app on the DNS Center UI. So if you're not doing SDA today, and if you have multiple clusters, you can integrate all these clusters with one single ISE. If you have a global ISE deployment. If you have a specific geo-specific ISE deployments, you can still go back with the previous model. You can go back with this model, right? You can integrate as many number of DNACs or the respective geo DNACs with the respective ISE clusters. But if you have one global ISE deployment, and if you want to stick to that global ISE deployment, and if you have multiple DNAC clusters, and if you're not running SDA, you can certainly go ahead integrating multiple DNS Center clusters with the same ISE. But the only exchange we do between these DNAC clusters is only the GBP data, only the policy-related data. So whatever policy you configure, whatever SGTs, access contracts you configure, that's the only data which gets exchanged between all these clusters. No exchange of SDA data. But let's say you have a fabric, you have an SD access fabric built, and if that's your environment, so you have multiple DNAC clusters here, you have one single ISE, you're running SDA fabric on all these clusters, if that's your use case, then you have to use this feature called multiple Cisco DNS Center. Right? Currently, it's a limited availability feature, which means you have to reach out to your Cisco representative or sales or an account manager. They should raise a request with the business unit. We will review your entire design because there are some limitations with this feature. If you're okay with those limitations, if your design fits our requirement, we will certainly release the packages for you to go and install that package and run this feature. Right? So it's all cloud update. Once we are okay with the design, we will request for every DNAC has something called a member ID and a serial number. We will request these two information. Once you provide this info, we can certainly release that MDNAC package. And once the package is available via cloud update, you can certainly install that package on the clusters and then reintegrate those DNACs back with ISE. And what are the limitations? What we have today is, so what you see here is something called an author and a reader node. And what we meant by that is the first cluster, whichever cluster integrates with ISE, this cluster can be a brownfield cluster, which means you can have your user or user-defined VNs, user-defined policies, user-defined SGTs. So this is the only cluster which can be a brownfield cluster. All other clusters have to be greenfield clusters, which means it has to be a fresh DNAC install, no fabric build, or you can even build a fabric, but you shouldn't have created virtual networks. You shouldn't have created SGTs or policies. If that's the cluster you have, then you can certainly integrate that with ISE, with that package, and then that second cluster, which will automatically come up as a reader node. And all this negotiation will happen through ISE. Which should be the author, which should be the readers, right? All the negotiation happen at the backend with ISE with that package. So any subsequent clusters which are getting integrated with that package will come up as reader nodes. So the first node is author, all other clusters will come up as readers. And what we meant by author reader, okay, I don't have a slide for that, but I'll explain it. So what we meant by author reader is, I can define a virtual network once on the author. It automatically gets replicated to all my reader DNAC clusters through ISE. Once I can define policy once on the author, the policy gets replicated to all other reader nodes, right? So with that, you can have consistent policy across all your DNS center clusters. You don't have to keep repeating the same policy again and again on multiple clusters, right? That's a benefit you get with this package. And the second thing is, as I said, you can create virtual network once, scalable group once, policy once. It gets seamlessly replicated. We have two more features called SD access shared transit, or shared SD access transit. I'll talk about that feature in the next slide. And there's a new feature which we have released called Lisp extranet. So this is another feature which needs this MDNAC capability as well, once you have multiple DNS center clusters. I'll talk about those last two in the next slides. So this is the package. You get the high-level design reviewed. Once the design is reviewed, we will release that package. Once the package release happens, all the packages will be pushed to your respective DNACs. Once the package is pushed to the DNACs, all DNACs will come up as an author node to begin with. But once you go rekey in the password and reintegrate back with ISE, that's when that negotiation happens, right? Automatically they negotiate, and the first node will come up as author, and all other subsequent nodes will come up as reader nodes, right? The first node will be author, and the remaining will come up as readers. So to begin with the package, all our author nodes, once the negotiation happens, whichever is the first node will come up as author, all the other nodes will come up as a reader. So yeah, so this is the slide which talks about what we meant by an author node, right? That's the first node which integrates. It can be a brownfield or a greenfield, doesn't matter. It can have user-defined VNs, we don't care. But the reader nodes can't have any user-defined VNs. It has to be a greenfield cluster. So when it comes to upgrade, so I have multiple DNS center clusters integrated to same ISE. So now I have to upgrade these clusters. What's the process to follow, right? We always recommend to upgrade the reader nodes first. The reason being, if there are new features available on the newer DNS center releases, we don't want that to impact your environment. So upgrade the reader nodes first. It doesn't matter which sequence, which reader node, but upgrade all the reader nodes and then come back and upgrade the author, right? So that now you don't have the discrepancy in the feature set. Let's say for some reason you lost your author node. It goes down, or the entire cluster is down, or your data center is down, but you lost reachability. But now you want to push or create a new SGT. So without an author node, you can't create this SGT because your author node is down. So we have given an option in the UI where you can force or you can promote a reader node to an author node. And again, we would recommend to do this only if you think your author node, you can't bring up your author node, or your author node is just down and for whatever reason, right? Only in that scenario, go ahead and promote a reader to an author. Once you do this promotion, let's say you promote your reader node 2 or a cluster 2, which is the reader node, as your author, there are a lot of, again, handshake which happens at the back end. Once this promotion request goes and hits ISE will now look for the current author, because it has to statefully take over its privileges back as an author node. But if your author node is down, obviously it will never get a response back, so it will keep retrying. It retries for twice and thrice. After that, you have an option on the reader node UI where you can say forcefully promote this reader to an author. So once you get that forceful promotion hyperlink, you can go click on it. With that, we will forcefully promote your reader to an author node, and we will also inform the other reader nodes that here is the new author. And that new author is the one which can do all your configurations now. Create VNs, create policies, create security group or the access contracts. So I highlighted that I'll talk about the shared SDA transit. So let's say you have multiple DNS center clusters. And okay, before I go there, what we meant by shared SD access, or what we meant by SD access transit, you have a cluster, you have a DNS center cluster, you have multiple sites. Let's say Fabric Site 1, Fabric Site 2, you have up to Fabric Site 10. All these Fabric sites are connected, has to be connected via some kind of a transit, because I have to carry these SGTs or VN information from one site to another site if I want to maintain or enforce policies. So for that, we have multiple transit options. One is called an IP transit. Second one is an SD access transit. And the third option is SD-WAN transport. So if you already have SD-WAN, you can certainly use SD-WAN to carry your VN or VRF information, or VN or SGT information across your WAN. If you're not using SD-WAN, if you have, let's say, a point-to-point links between these Fabric sites, or you have your own dark fiber links between these Fabric sites, you can either use IP transit or SD access transit. The benefit you get with SD access transit is we seamlessly carry these tags over a Lisp and a VXLAN tunnel from one site to another. So it's like extending your Fabric across your WAN, right? Irrespective of your WAN type, what you have. So that's SD access transit. With IP transit, we don't carry these tags. You have to manually carry it, or you have to do, it's up to you how you carry, because once we do an IP handoff, it's just a pure IP packet. So that's the benefit you get with SDA transit. Multiple Fabric sites connected via dark fiber or a metro Ethernet, where Jumbo MTU is supported across your WAN. Then we can seamlessly carry this VN and the SGT information. So for that, we use SD access transit. But what if I have multiple DNS center clusters and I want to carry this tag seamlessly across multiple clusters and multiple sites? So that's where this shared SD access transit will come in. So multiple DNACs, each DNAC has its own Fabric sites, and all these DNACs are connected across my WAN. Now I have to carry this SGTs and VNs across these clusters. That's where you can use this SD access shared transit. And for this feature, you need that MDNAC feature. Without MDNAC, you can't enable this shared SD access transit, right? And that's the prerequisite. So what happens with this is, you create shared SD access transit on the author, it automatically replicates that across all the readers, so that you can now use this shared SD access transit within all the Fabric sites on that particular cluster, right? Lisp extranet. So today, within a Fabric site, so let's assume this is your border nodes. Border nodes connects to an upstream device called Fusion, and that Fusion can be a switch, a router, or a firewall, right? We always recommend it to be a firewall because of more security, what you can get with firewall compared to a switch or a router. But let's say it connects to a firewall or a router or a switch, and the Fusion responsibility is to route leak, right? We're using BGP route targets. But using BGP route targets, route leaking is complex. Not everyone is well versed with doing the route leaking with BGP route targets. And it's all manual configs today. So we have introduced this feature called Lisp extranet, where you don't need the device called Fusion to route leak. Second thing, you don't have to do any of those BGP route targets route leaking, because we will use Lisp itself within the Fabric to do that route leaking for you. And it's very straightforward. You don't have to do anything. Go on the UI, select which is your source virtual network, destination virtual networks, just say route leak. So it's a two-way route leak what we do using Lisp extranet, and we use the Lisp instance IDs at the back end to do that route leaking instead of BGP route targets. So it's completely UI driven. You don't have to do any manual configs anywhere. So this is within a site, right? Within one Fabric site, I can do this. What if I have multiple clusters, multiple Fabric sites, and I want to do this route leaking? So that's where this Lisp extranet, with MDNAC comes into play, right? So I can create that policy once on one of my author node or on my author cluster. It seamlessly replicates that policy across to my other reader nodes as well. So now that policy is available on the reader nodes, and then I can go attach this policy to, to whatever site I want on the respective reader nodes. So this is where you have an edit option on the reader nodes to attach that policy to a respective site. Right? So this is Lisp extranet with policy, but this also needs that MDNAC feature for it to work. Right? So Lisp extranet, the shared SD access transit, and all the other use cases which are called out. I think this is what ISE brings in, into the Fabric or into the SD access architecture. I think that's all I have. If there are any questions, and one more thing before I forget, surveys, feedbacks. We consider this very seriously within Cisco. I would request you to please fill out the surveys. Let us know what went well. I'm part of the business unit. If there's any feedback on the solution, I'm happy to take that. All the comments for the feedback are anonymous, but I'll certainly make sure I'll read all those comments and make sure I get better on it. Okay, thank you. I hope you enjoyed it. If there are any further questions, please, I have some books to give away. You can reach out to me. Yes, sir.
No, sorry, I dropped it.
Okay. Okay, we can take that offline. That's fine. Any further questions? Okay.
Our policy pushed out to all of the clusters. Can you exclude that policy for one cluster?
Can you come again?
Can you exclude one policy for one cluster?
Okay. So the question is, can I exclude the policy to one of the DNAC cluster if I'm using that MDNAC package? Today, no, we can't do that. By default, it pushes. But it's up to you whether you want to use that policy on the cluster or not. Because if there are no active endpoints having that SGT, then the policy will never be used on that cluster. But the push anyway happens to all clusters. Yeah. Thank you. Hope you have a good rest of the Cisco life.